For part C, we have x over absolute value of x minus 3. And since it's an absolute value, we need a piecewise function. So to the right here, I've drawn kind of our f of x as a piecewise function. We need the positive and the negative version of that. So we need to establish the boundary of the positive and negative. And that's going to be based on when the inside absolute value is equal to 0. So at x equals 3, we have our boundary. And our positive version is going to be based on x is greater than or equal to 3 or greater than 3. Can't be equal to 3 because we're dividing by 0 there. And then for the negative, it's going to be when x is less than 3. And it is discontinuous at x equals 3 because we're going to divide by 0. So when we look at the positive version, well, it's just going to end up being x over x minus 3. We don't change anything for the positive version. For the negative version of that, we're just going to take the opposite of the x minus 3 and make it negative. So I'm going to put the negative on top and then take away the absolute value brackets. So I get this. So these are my two piecewise functions, and now I can apply my limits from the left and right hand sides because I can see which expression I'm going to use for each limit. So the limit as x approaches 3 from the positive side, that's going to be using the green function. So I'm going to use the green function for that, for the positive side. And as it x equals 3, I'm going to end up with 3 on top over 0. But I'm approaching 0 from the positive, I'm approaching 3 from the positive side. So it's like 3.1. So I'm going to end up with 3.1 minus 3, which is positive. That means I'm approaching 0 from the positive side. Okay, so if I'm approaching 0, the limit is infinite because it's positive over positive. It's going to positive infinity. So I know on this graph then, as I approach my vertical asymptote at x equals 3, on the right-hand side, it's approaching infinity, positive infinity like that. Okay, and as I approach it from the left-hand side, or 3 from the negative side, I'm going to use the negative version of this. So I'm going to end up with 3 negative of 3 over, and this time I'm approaching 3 from the negative side. So for example, 2.9. So I'm going to end up with 2.9 minus 3, which is going to give me negative 0.1. So I'm approaching 0 from the negative side. Okay, so I'm approaching from the negative side of 0. So I'm going to end up equaling, well, I'm dividing by 0, so I get infinity. And I'm approaching 0, I have negative and negative, so this is going to be positive infinity. So this graph is going to approach positive infinity from the left-hand side. Okay, so we have on both sides of that asymptote, it's pointing up. So then we can look at what's happening at infinity, the endpoint behavior. So when I take a look at the endpoint behavior, as x goes to positive infinity, I'm going to use the green. And I can see that, well, the negative 3 becomes insignificant. So basically, I'm just going to take the ratio of x over x. Well, that's equal to positive 1. Okay, so the limit as x goes to positive infinity is going to be positive 1. So I'm going to have a horizontal asymptote at positive 1. So I'm going to draw my horizontal asymptote in here at plus 1. So it looks like the graph is just going to continue along the asymptote like this. I'm going to check out what's happening as I go to negative infinity. That means I need to use a bottom function. So I'm going to end up with negative of negative infinity. So basically, I can maybe analyze it a little bit more simply like this. I'm going to be looking at, as x goes to infinity, the negative 3 becomes insignificant. So I end up with negative of negative infinity divided by negative infinity. That's going to be negative 1. That's going to be a negative 1 ratio. Okay, negative x over x is negative 1. So at negative 1, I'm going to have a horizontal asymptote going to the left. Okay, so that's going to be y equals negative 1 and this is y equals positive 1. So this red graph is going to drop below the x-axis and follow that red asymptote. Now, since it drops below the x-axis, it's probably going to cross the the y equals 0 line, and I could find zeros by looking at the numerator of a function. So if I take a look at the numerator here, I'll choose maybe this color here, that the numerator is where I look for zeros. That's going to cross 0 at x equals 0. So then my coordinate, I'm going to have a point there, and then I could just draw my graph through that 0 point. So I'm going to go through here, I'm going to come across through here. It's going to follow the horizontal asymptote to negative infinity. Okay, and again, notice that the red line crosses an asymptote, horizontal asymptote. That's perfectly okay to cross horizontal asymptotes because horizontal asymptotes are endpoint behavior. They only tell you what's going on way out at infinity. We cannot cross vertical asymptotes though, so we don't want to mix those two things up. So that's what my graph looks like, and those are the limits.